Hello, everyone. Welcome. Glad to see you all. Thank you to those of you that are turning on your cameras. It allows me to kind of see some reactions while I'm talking, and that helps me a lot. So I appreciate that. I hope you're all doing well. This is our second class, and I'm glad to see you all here. Let me start out with just a couple of preliminary things. So hopefully you got this in your email. This is a kind of to-do this week list, all right? And I'll try to be sending you these every week, so you kind of know where you are and what you got to do that week. So I'll probably try to send them out on Monday. So watch your inbox on Monday on your Pipeline account under email, and I'll just make sure you have a list of things you got to do that week so that you can keep up and not fall behind. Again, the most important thing about this class, if you want to be successful, is not to fall behind. All right, so you got to keep up. So this week, we got to attend class on Monday and Wednesday. So if you're here, you're doing that. If you can't come at this time, you can always watch the recorded lecture. I will post these on Canvas right after the lecture, so you'll be able to see that. Make sure you have access to Mastering Chemistry. I think there's 196 students registered in this class, and I see that about 188 of you have access to Mastering and have registered. So it looks like there's just a handful of you that haven't. If you still haven't registered for Mastering, make sure you do. Your first assignment was due 3 minutes ago, right? And so that starts counting for credit. Just a quick word, if you don't get the assignment done right on time, don't panic. You can still do it. So the assignment that was due today at 2, you can still complete after class if you'd like. You do lose a little bit of credit. You lose about 4% of the credit for every hour that passes by. So if it's 24 hours later, by the time 24 hours have passed, then it's too late to really get much credit for anything you do on Mastering. But if it's just a few minutes late, it's not that big a deal, okay? Then thirdly here, attend the pre-lab lecture on Wednesday, all right? Make sure you do that today from 5 to 6. If you can't do that, then watch the recorded lecture as soon as possible afterwards. In the pre-lab lecture, you'll get the instructions for how to purchase the simulation software. That again is going to cost about $60. I apologize for that, but it's just the way it is this semester. And you'll get instructions for how to do that today. Some of you may have already purchased it, but if you haven't, just wait till after 5 today, after that lecture, and then you'll get more instructions on how to do that. All right, and then make sure you do your Mastering assignments. This week, there's 4 of them that you should do. Introduction to Mastering Chemistry, which hopefully I see many of you have already done. Today's pre-lecture assignment, which I see that many of you have already done, so very good. And then you have a couple more. One is the post-lecture assignment, which is due tomorrow at midnight, all right? So that's after today's lecture. And then there's the problem set due Friday at midnight, and that's the long one, okay? So let me stop there for a second and see if I see a couple of you have questions, so I'm gonna call on you. Let's see, Hey Yoon Kim?
Yes.
You have a
Okay.
question?
Yes, I just have a quick questions about the pre-lab. So I saw on the homepage, and it says that there's like a live pre-lab lecture like 5 to 6.
Today,
but then
correct.
on the bottom it's listed like whichever CRN code.
Correct.
And there's like a 6 to 9. So I don't know.
Correct. Okay, very, very, very good question. So everyone listen carefully here. The pre-lab lecture today at 5 to 6 is for everyone that's taking this class. Okay, It doesn't matter what CRN you are. You will be going to the pre-lab lecture today from 5 to 6. That's universal. If you can't attend that, you can watch it shortly afterwards as it will be posted on the Canvas page. In terms of your actual lab time, that depends on your CRN number. So you can look at that table, which I can display here, which I think I displayed last time, but you can look at it on Canvas, and that'll tell you at what time you go to lab. There are 2 asynchronous labs, which you basically do on your own, but you have office hours for the instructor that you can go to. Okay, thank you for your question. Ashley Clark, did you have a question?
Yeah, I asked to switch my lab section, and I emailed Professor Hughes, and he said that I'd be able to. How would I join the lab section today?
You can go ahead and go to it today. You'll have to have, I think you'll have to find a person to switch with if you're actually going to switch, because every single section is full.
Okay. I don't know. He said that I'd probably be able to switch, so I
Okay,
think maybe he did find someone for me. I don't
perfect,
know.
perfect. So talk to him today after the pre-lab lecture.
Okay, thank you.
Okay, thank you, Francisco.
Oh, yeah, I have a question. So we should have received an email with the Zoom link to attend the pre-lab lecture, correct?
No, the pre-lab lecture is listed on the Canvas homepage.
Okay, so there's just one link for the pre-lab
Correct.
lecture.
For everybody. Yep, yep.
Okay, thank you.
Okay, you're welcome. Any other questions? Okay, let me go back to sharing my screen. Remember, if you have a question, raise your hand. I'll keep an eye on that. If while I'm lecturing, and I ask a quick rhetorical question, feel free to unmute yourself in order to answer that question. Okay, I really appreciate that input. Okay, so let me just go back to this. I want to say a little something about tutoring. All right, so you guys will be working on problem sets. These problem sets can be difficult. There can be some difficult problems on there, and sometimes you'll get stuck, right? So that's where we have a lot of help for you, okay? You have my office hours that you can come to after class every day, and then also Tuesday and Thursday from 2 to 4 by appointment. Then in addition, we have 3 fabulous tutors, which I'm going to introduce to you in just a minute. Their names are Shea Alexander, Hunter Heath, and Thomas McCoy. Their information is all listed on the Canvas homepage, all right, including their email addresses and their Zoom links. They will be hanging out on Zoom during all these times that you see here. So starting today at 4:30, Shea Alexander will be on her Zoom link. You can join that at any time, drop in to ask her questions. From 7 to 9, Thomas McCoy will be on his Zoom link, and so on, all right? So you can see, starting when we finish today's lecture, you will have all the material you need to complete that problem set. And notice that for most of the day, today, tomorrow, and Friday until 6, you have help available, okay? So make sure you use that help. These people are super good. They're super smart. They did very well in my class. And so I would like to introduce them to you. Oh shoot, I forgot this. This is what I meant to be showing you that entire time. This is the schedule that is on the home page in Canvas, okay? And you can see the times here, right? And their Zoom links are here, okay? So without further ado, let me introduce you to them. Let's start with Shea. Shea, are you here?
Yeah, I'm here.
Okay, let's see. Do you want to introduce yourself, Shea?
Yeah, I can introduce myself.
Awesome.
Okay, cool. So hi everybody. My name's Shea. I'm from Carpinteria. It's like right next to Santa Barbara. And my major is biology. So I love biology, but chemistry is pretty cool too. And I took this class spring semester. So I'm like pretty like fresh with chemistry. I don't know. I just like, yeah. Anyways, but and I think that's like it for like introduction wise. If you need help, just like ask. I love helping you guys, and we have like kind of like this like solution manual that we can compare to like your mastering chem. So if you get stuck on those, and if I like am not sure how to do it, I can always like refer to that and help you guys. So yeah.
Perfect. Thank you, Shea. How about Hunter? Hunter, can you introduce yourself?
Yeah. Hey everyone. My name is Hunter. I am from Los Angeles, California, so just like an hour and a half south. I am a chemical engineering major, so I just went through the Gen Chem 1 last fall. I was going to be taking organic chemistry, but I'm going to wait till we get a lab. Yeah, I'm really looking forward to working with all of you. I really like chemistry and yeah, problem solving. So please come to my tutoring hours if you have any questions.
Thank you, Hunter. How about you, Thomas? Are you there?
Yeah. Hey everyone, I'm Thomas. I'm from Kailua, Hawaii. My major is mechanical engineering. It's been like 2 years since I took 155, but I took 156 last semester, and the knowledge is pretty fresh. So yeah, I'm here if you guys need any help.
All right. Thank you guys so much. Thank you for being here and for introducing yourself. Like I said, these three were my top students last semester, and that's why I asked them to be the TAs. And so they will really be able to help you. So make sure you take advantage of that. In fact, you know, even you're working on your problem set, you can just log into the Zoom, and then as questions come up, you can ask them. Other students will be on that as well. And so they'll just answer questions as they can. And again, you have lots of hours available, so make sure you use that resource, okay? It's hard to answer questions over email, so it's much better to be involved during those hours in the Zoom, all right? Okay, thanks everyone. Thank you, Thomas. Thank you, Shea, and thank you, Hunter. I'm gonna go back to my share screen here. Okay, great. Great. And I'm gonna do that. All right. Let me just get a couple things situated here so I can navigate. All right, so let's start just a little review from last time. If you remember at the end of last time, what we did was we were looking at energy, and we concluded with a few things about energy. First of all, energy is conserved, right? It's neither created nor destroyed. So I want you to know that. We also said that, systems tend towards lower potential energy, right? So if I have this pen here, right, and I drop it, it falls, right? High potential energy to low potential energy, right? We talked about that a little bit. And then we also said that energy disperses, right? So if you have like a hot cup of coffee, the thermal energy in that coffee will disperse over the entire room, okay, over time. It never goes the other way. Energy doesn't concentrate, okay? That's called the second law of thermodynamics, and it turns out that that's the law that drives everything that happens. So we will be looking at that law more later on in this course, okay? All right, so we're gonna jump into units of measurement, and then we're gonna look a little bit at significant figures, and then we're gonna look at solving problems. You already watched a video, or at least I hope you did before coming to class, on both units of measurement and significant figures. So I'm not gonna spend a lot of time on these. I'm gonna assume you saw the video. If you haven't seen the video, which was assigned, then make sure you go back and watch it after class, because that material is just as important. The material in the videos is just as important as the material I cover in class, okay? But I'm just gonna assume that you have seen those videos, so I'm gonna just cover it very, very quickly. Units are super important. They help us to quantify things, right? If you look at even things like Olympic performances, right? When there's an Olympic performance, people want to give it a number, right? Why do they want to give it a number? Because it's one thing to say this performance was good and that one was okay. It's another thing to say this performance was a 7 and that one was a 10, right? When you give something a number, you can quantify it, right? And so that's what units are all about. How do we quantify things? With a number and a unit. All right, so we say that, you know, something is 1 meter long. That tells us how long it is, and it allows us to compare the length to other objects, right? So, so units are super important. When units get screwed up, bad things can happen. So, for example, this is a Mars climate orbiter. We sent this to Mars on a mission, right, to monitor the surface of Mars. When this was launched in the 90s, the engineers who launched it and the engineers who were flying it used different units. And because of that, the thing crashed into the surface of Mars and it cost over $100 million. So a unit mistake made a huge difference. We're gonna use units a lot in this class because they're gonna help you to see correctness in calculations, okay? You saw in the video already the base units, right? Like the unit of length is the meter, mass is kilogram, time is second, temperature is Kelvin. These 4 units are the most important, okay? You also saw the different temperature scales, right? The Fahrenheit scale, the Celsius scale, and the Kelvin scale, okay? And we'll be using the Celsius and the Kelvin scale primarily, all right? Just to give you a little bit of a calibration, for those of you that live in the United States, I know there are some people here that are actually tuning in from Europe and from other parts of the world, so that's kind of fun. You guys probably are more used to temperatures in Celsius, but in the United States, we're not. But 0 degrees is where water freezes, so if you're near a place where water is freezing, then you know you're about 0. In the fall, on a very brisk day, it's about 10 degrees Celsius. The temperature in your room right now, it's probably 22, or at least that's normal room temperature, probably a little warmer than that today. And then really hot temperatures are in the 40s, like a summer day in Death Valley, okay? These are the equations that convert between them. I'm not going to do any examples on these because you've probably seen these before, but you will have some assignments in your problem set just to make sure you can convert between these different temperature scales, okay? With these units, we're also going to use these prefix multipliers, all right? And for example, kilo means 10 to the third, milli means 10 to the minus third, all right? And we'll be using these throughout the semester, so it'll be very good for you to get familiar with this table and those prefix multipliers. We'll talk more about those in a little bit. All right, we also can sometimes have derived units, which are combinations of other units. So for example, you would report your speed or your velocity in meters per second, right? And notice that's 2 units combined, meters in the numerator and second in the denominator. Super, super common. We'll be doing that a lot too. A lot of derived units, which are combinations of these basic units, okay? Volume, so units of volume are gonna be units of length squared, right? So for example, here's a 1 centimeter cubed, right? 1 centimeter by 1 centimeter by 1 centimeter, all right? And those are, hang on for a second. I can't figure out why this is not working for me. Pin that, there we go. Okay, so those would have units of centimeters cubed, which is a derived unit as well. Another common unit, another common derived unit is unit of density. Density is volume over mass. Let me just write that down so that you write it down as well. Density is mass over volume, okay? So the units of density are gonna be the units of mass, which can be kilograms or grams. Most typically we use grams in density. And then volume is, we're gonna use centimeter cubed for density. So it has units of grams per centimeter cubed. All right, again, another example of a derived unit. Notice the values of density for different substances here in this table, right? Water is a good reference. Water has a density of 1, right? 1 gram per centimeter cubed. Really dense metals can go up into the teens and even up as high as above 20 for platinum, one of the most dense metals, right? You may have heard an old joke that says something like, what weighs more, a ton of bricks or a ton of feathers? Let's see, does anyone want to answer in the chat or?
Neither, they're the same.
Yeah, it's very, very good. So bricks and feather, a ton of bricks and a ton of feathers have the same mass, 1 ton, right? What's the difference between them is the density, right? Bricks are very dense, feathers are not very dense, right? So we'll be using density a lot. We're going to see in a minute, a little bit later, that density is a conversion factor also between mass and volume. So we can use that quite a bit as well. All right, in your book, you'll find plenty of, you'll find tables like this that have conversion factors between units, okay? These are gonna be important. We're gonna be doing a lot of conversions. And if you have the physical book, you can see that at the end papers at the very end have a whole bunch of conversion factors as well. And in the ebook, you can access those as well in a table, okay? All right, so those are units. Again, I went through it fairly quickly because you saw the video on it already. You're gonna have to get very comfortable with units. We're gonna use them a lot, all right? Let me talk a little bit about significant figures. And again, you also saw a video on this, so I'm not gonna go through the details in too much, I'm not gonna spend too much time on the details, but look at these measurements. These are the reported carbon monoxide concentrations in Los Angeles, different years from 1990 to 2017, okay? And carbon monoxide, by the way, we talked about last time, right? It's a poison. It actually binds to hemoglobin and it causes problems because it displaces oxygen, right? So we don't want a lot of carbon monoxide in the air. First of all, notice what's happening to the carbon monoxide in Los Angeles from 1990 to 2017. What kind of a trend do you see?
It's decreasing.
Decreasing, right? That's a good thing. We've figured out ways to clean up the air over most of our cities, and as a result of that, most cities are seeing trends like this, where pollutants are decreasing in the air, and this is an example. The main thing that is responsible for this is not fewer cars, because we actually have more cars between 1990 and 2017, but technologies such as catalytic converters, which takes the carbon monoxide out of the exhaust, right? So, okay, so that's the first thing. What else do you notice about these two sets of measurements?
One is rounded.
So one is reported to more precision than the other, right? So you see, this is more precise, this is less precise. So that tells me when scientists report numbers, right, they report them in a way that reflects the precision, right? So when a scientist writes 2.8, for example, like right here, right, they mean that they're sure of the 2, and then the 0.8 is estimated, right? When you record one significant figure, that means that this number can be off itself, right? So usually this comes from the way we read instruments, right? So if you look at, let's say, reading the volume on a volumetric flask like this one, right? You read at the bottom of the meniscus, which is right here. And this is the 4 milliliter mark. This is the 5 millimeter mark, the 6 millimeter mark, etc. Notice there are marks for every 1/10 of a milliliter, right? So how would we report this measurement? We'd say, we're certain of the 4, we're certain of the 0.5, right? So we'd write 4, we're certain of that. 0.5, we're certain of that. But now we have to estimate between here and there, right? So we mentally break that up into 10 spaces and we try to estimate, okay, that meniscus is probably at, what do you think? 7 maybe, right? So we would say that 4.57 is our estimate. We're using 3 significant figures here to report it because of the way the instrument is calibrated, right? Look at here, here's temperature on a thermometer, and again, 100, 105, 110, those are all certain, right? 101, 102. But then you can see that this is probably about, you'd probably say maybe 102.9, right? Or 103.0, hard to tell, right? Is it at the 0.9 or is it at 103? That's why this part's estimated. But the point is that if the instrument is this, you would use 4 significant figures. If the instrument is this, you would use 3 significant figures, right? So what you put down as your measurement depends on the instrument you're using to make the measurement, okay? And that then determines how many significant figures you have, okay? So how do we count significant figures? Again, you already went through this on the video today, so just very quickly, all non-zero digits are significant. Interior zeros are significant, leading zeros are not significant, and trailing zeros are the tricky part, right? And again, I'm going to refer you to the video to look at how you deal with trailing zeros, okay? There are some numbers that are exact. So for example, when I write 12 inches, actually let me write 100 millimeters is equal to 10 centimeters, right? That is by definition true, right? So these numbers would be exact, right? Or if I say, here are 5 pennies, right? I've counted them out, 1, 2, 3, 4, 5. That number is exact, okay? Exact numbers have an unlimited number of significant figures, yeah? They come from counting individual objects, like I said, like 5 pennies. They come from definitions, or they come from integer values in equations, right? If I say, if I have an equation that says 2 pi r, for example, and I have a 2, that's unlimited number of significant figures, okay? All right, let's do some examples. So again, help me out here. You can unmute yourself and answer these questions. How many significant figures in this number right here?
4.
4.
Correct. There are 4. 1, 2, 3, 4. This 0 only serves to mark the decimal point and therefore is not significant. How many in this number?
5.
5.
Correct. Very good. 5. 1, 2, 3, 4, 5. Interior zeros are always significant. Okay. How many significant figures in this number?
Unlimited.
Unlimited.
Unlimited, right? This is the definition. Yes, a meter means 1/10 of a meter, right? So that's by definition true. So this has an unlimited number of significant figures. How about here?
4.
4.
4, correct. 1, 2, 3, 4. Very good. How about here?
1.
1.
Correct. Just one significant figure, right? 1. All these zeros are just marking the decimal point. They're not significant. So only the 2 here are significant. How many here?
Ambiguous.
Ambiguous.
Correct. Exactly right. Very, very good. That's ambiguous. Okay, let me have you try one here. So let's do a quick poll and go ahead and answer this question. All right, I'll give you 10 more seconds to answer. Most of you have answered, a few of you haven't. Go ahead and answer. Okay, perfect. The right answer is B. And wow, almost everybody got that. Let's see, the main wrong answer was C. So what's going on with their C5? So these zeros are only mark the decimal point, so they are not significant, okay? And some of you put 3 as well. This 0 is significant because it follows a non-zero digit, okay? So again, please, if you missed this, make sure you go back and you watch those videos that were assigned before class, because that goes into more detail on this, all right? Perfect. All right, one more question for you. Let's go ahead and have you answer this one. I noticed that the polls in class are not graded. The reason I use these polls is because remember I was telling you earlier that the way you learn is by recalling and applying, right? So this is forcing you to recall and apply what we just covered, and that's going to cement those pathways in your brain, right? So it also helps me to see where you guys are. In normal classes, I actually use a system where these would be graded, but I can't do that in this remote class, unfortunately. But I really encourage you to participate. All right, 10 more seconds. All right, the correct answer is D, none of the above. And again, very nice, almost all of you got that. The reason it's unlimited is because this is the definition, right? 12 inches equals 1 foot. So when things are defined, right? They have an unlimited number of significant digits. So when you're doing calculations, this kind of thing will never limit your significant digits, right? Because it's a definition, okay? All right. All right, so next we have to know not just how to figure out how many significant digits are in a number, but we have to figure out also how to preserve that precision in our calculations, all right? So when we do calculations, you want to preserve the precision. And so there's different rules for different kinds of operations, all right? And again, the video goes over this in more detail, but know that when you multiply or divide measurements, the result has the same number of significant figures as the measurement with the least number of significant figures, right? So for example, if you do something like this, right? If you do 5.02 times 89,655 times 0.10, and you punch that all into your calculator, right? You're going to get 45.1.0118, right? Is what you're going to get in your calculator. Oops, that's not very clear. 45.0118, okay? Now, how should you round this to preserve the precision in these numbers? Well, according to the rule that we just learned, right? This number has the fewest number of significant figures, so it limits the answer, right? So the answer should have how many?
2.
2.
Correct, 2 significant figures. So that's the correctly rounded answer. Does that make sense?
Yeah.
Yeah.
All right, here's one for you to try. Go ahead and try this one. I see some of you are answering the poll in the group chat. That's not where you enter the polls. You should be able to see the poll pop up on your screen, and you can answer it there, okay? Don't answer the poll on the group chat. All right, 10 more seconds here. I don't think there's a way to resubmit. All right, I'm gonna close that one down, and the correct answer is just 1 significant digit, right? Just 1. Why is that? Because look, this has how many significant digits?
3,
3.
This has
5,
5, but this only has 1, right? So when you multiply all this together and put it in your calculator, you're gonna get some number, but the precision is limited by this, which only has 1 significant digit. So you report that to only 1 significant digit, okay? Be very, very careful with significant figures are gonna be, significant digits, significant figures, they mean the same thing, okay? Again, most of you got that, but a few of you put B, probably because you thought that this was 2 significant figures. It's not, it's just 1, because remember, this leading 0 is just marking the decimal point, right? So it's not significant. Again, if you're confused here, make sure you go back and watch the video on significant digits, okay? All right, good. Now, what about addition and subtraction? Well, it turns out the rules are a little different for addition and subtraction, all right? So in addition and subtraction, what determines the number of, what you look at, instead of significant digits, you look at number of decimal places, all right? And the rule is this: when adding or subtracting measurements, the result has the same number of decimal places as the measurement with the fewest number of decimal places, all right? So let's say I am going to do this addition, 2.345 plus 0.07 plus 2.9975, right? If I put that in my calculator, I'm gonna get 5.9975. 0.4125 as my answer, okay? But according to this rule now, this has 2 decimal places, all right? It has one significant figure, but 2 decimal places. So remember, for addition and subtraction, we focus on
Decimal places.
yeah? And for multiplication and division, we focus on significant figures. So here it's decimal places, so 2 decimal places. So when we round that, we're gonna round it to 2 decimal places, 5.41, all right? So notice how weird this is, right? In this case, the number of digits, the least number of digits is 2, so you get 2 in your answer because that's multiplication. In this case, this only has 1 significant digit, but look at how many significant digits in my answer, 3, right? Because here we go not by significant digits, but by decimal places.
Decimal places.
Exactly right, okay? So does that make sense? All right, let's have you try one. Go ahead and try this one. All right, 10 more seconds. All right, the correct answer is B, and woohoo, almost all of you got that right, 86% of you, so nice work. It's 0.50, right? Why? Because when you subtract this from the other one, right, you do, let me just stop that. 18.52 minus 18.02, and you get 0.50. And again, 2 decimal places, 2 decimal places, so 2 decimal places here, right? That's the way that works. Does that make sense? All right, any questions? Okay, I don't see any questions, so we'll keep going here. What about rounding? If the last digit is from 0 to 4, you round down. If the last digit is 5 to 9, you round up, okay? Now, if you want to get exactly the right answer, like the right answer that's exactly right at the in the appendix at the end of the book, or the answer that's exactly right in Mastering Chemistry, you got to avoid rounding error, okay? I'm not going to, which means that you only round at the end, but you got to keep track of significant digits in the middle to sort of get to the right answer, okay? So just keep that in mind. But anyway, let's see if we're going to round this number to 2 significant figures, right? 8.549, right? We're going to round to this digit, right? So we look at the next one, we say that's 4, right? So we round down, right? 8.5. Yeah? All right, here's one for you to try. Go ahead and try that one. Five more seconds. Okay, the correct answer is B, and look at that, nearly 100% of you got that. So very, very good. Thank you for paying attention and for working on that. I really appreciate it. let me just say one more thing. Let's say you have a number like 8.439, all right? And you want to round that to two significant, sorry, that's not what I want. Let's say you want 8.449, and you want to round that to two significant digits, okay? So this is where you want to round to. You only look at this digit when rounding, right? You don't look at the next one. So for example, it's tempting, and I see this mistake sometimes. People will say, oh, okay, this rounds up to 5, so then I should round that up. That would be incorrect, all right? It should be, this should round to two significant figures to 8.4, okay? All right. Now, what happens if you have addition and subtraction and multiplication and division, right? So let's say you have both operations. How do you deal with that? Well, you got to follow the right rules for the right operation, right? So for example, let's say we're doing this right here, right? Where we have 5.432 minus 5.41 all over 2.0. How do we do that to the right number of significant digits, right? So what we got to do first is we'll do the numerator, right? When we do that on our calculator, we're going to get an answer like 0.022, right? And how many significant, well, sorry, not how many significant digits. Since this is subtraction, how many decimal places are we allowed up here?
2.
2 decimal places, right? Because we have 2 decimal places here, so we get 2 decimal places here. So we're going to underline that to remind us that, aha, that should only be 2 decimal places, right? And then we're going to divide by 2.0, right? Now we have the multiplication division rule, right? So how many significant figures in the numerator here? How many significant figures? Not decimal places. How many significant figures?
2.
Not 2, because remember, we underlined this to remind ourselves that this is the least significant digit. We're just holding this onto this just so we don't get a rounding error, right? So how many significant digits?
1.
1, right?
One.
Only one significant digit. This really is 0.02, right? Which just has one significant figure, okay? Does that make sense?
Yeah.
Okay, so when we do that, right, we're going to end up with 0.011, right? But we only get one significant digit. So when we round that to the right number of significant digits, it should only be 0.01. So notice it's hard to tell just from here how many digits you're going to end up with, right? You got to follow the steps for each, follow the rules for each step first, and then you can find out, here in my answer, I should only have one significant figure. Does that make sense? Yeah?
Yes.
Perfect. All right, let's have you try one. Here we go. Be careful here. All right, 10 more seconds. Five, four, three, two, one. All right, so the correct answer is B, 2. And I see that the majority of you got that, but some of you were a little bit off. So let's see what's going on here, right? So remember, you got to follow the rules for addition and subtraction for the first part first, for the top, right? So when you do 14.84 minus 14.24, what do you get there in the numerator? 0.60. And you get 2 places of the decimal, right? Why? Because both of these have 2 places of the decimal. Okay. Then you do the division part. Now you have how many? Now you go by significant figures. How many significant figures up here?
2.
2.
2 in the numerator. How many in the denominator?
3.
3, right? So 2 and 3. So how many are you allowed in the answer?
2.
2, right? 2, because that limits the number of significant figures. So the right answer was 2. Again, most of you got it. If you put A or C, you're not understanding your significant figures rules very well, and you should go back and review this. Okay. Okay. Great. So now we know all about significant figures. We know how to work with them. And the reason we did all this is because we ultimately want to be able to solve problems. All right. Now, this is probably the most important thing you're going to learn in this class. How do you take a problem and solve it? And this is probably not important just for chemistry or physics or for whatever you end up doing. This is just a good life skill, right? How do you get a problem that you're looking at and how do you solve it? So I'm going to be asking you to solve a lot of problems this semester. And it's not because I'm trying to torture you, right? It's because I want you to learn how to solve problems. And that just takes a lot of practice, okay? It doesn't just come easily and it doesn't come overnight. It just takes practice after practice after practice, all right? So we're gonna look at how to solve problems. We're also gonna look at pay special attention to units, all right? And we're gonna be doing a lot of unit conversions. And in fact, some problems you can think of as just unit conversions, all right? So we're gonna pay special attention to units. So for example, let's suppose we wanna do a unit conversion like 12.5 inches. And let's say we wanna convert that to centimeters, right? And we know that 2.54 centimeters is equal to 1 inch. This is our conversion factor, all right? It tells us the equivalence between 2 units. So how do we do that conversion? We write 2.54 centimeters over 1 inch, like that. Why do we write it that way? Because look what happens. You treat these units like algebraic quantities, right? It's kind of like saying A times B over A, right? Or 1A, 2B, 3A, right? What happens is these would cancel, right? If this was just purely algebraic, and your answer would be what? 2/3 B, right? We're gonna do the same thing here. These are gonna cancel, right? And my answer is gonna be 31.8 centimeters, right? I get this unit left over. So as you're working through these problems, always write down your units and always cancel them, right? Just like I'm showing you how to do right here, okay? Here's why this is important. Let's say that you did it wrong, and let's say you wanted to convert the other way. Let's say you wanted to convert from 31.8 centimeters and you want to convert back to inches. Well, look what happens if you use the same conversion factor. Right? The units don't cancel. In fact, if you were to carry out the units here, you'd get 80.8 centimeters times centimeters, which is centimeters squared over inches, right? And this unit is nonsense. So notice what happened here. By paying attention to my units, I caught my mistake, right? What was my mistake?
The units didn't cancel.
The units didn't cancel. And why didn't they cancel?
If the inches was on the bottom when the centimeter should have been on the bottom.
Exactly right. I have to flip this. So really it should be 31.8 centimeters times 1 inch over 2.54 centimeters. Now my units cancel, right? And I get my 12.5 inches back, right? So this is why it's so important to always write down your units. You'll catch a lot of your mistakes if you do that, okay? By the way, the reason I can just flip this is because these are equivalent, right? These two things are equivalent to each other. So if I divide, let's say, by 1 inch, what do I find that this is equal to? It's equal to 1, right? And 1 over 1 is 1. So I can always, if I have an equivalence like this, I can always write it both ways. I can write 2.54 centimeters over 1 inch, or I can write 1 inch over 2.54 centimeters, right? I can write it both ways depending on which way I'm converting, okay? All right, so let's do some examples. Let's say I want to convert 55.2 milligrams to grams. 55.2 milligrams, and I want to convert that to grams. Well, I have to know what milli is. A milli, equals 10 to the minus 3, right? From that table that I had showed you earlier. So the way I do this conversion factor, notice, and this is really nice, and I encourage you to always do it this way, because then you'll never make a mistake. Just write milligram twice. So you know that milligram has to go in the denominator, right, in order to cancel this. And what is a milligram? Well, milli is 10 to the minus 3, right? So notice what I've written here. 1, 10 to the minus 3 grams, 1, 10 to the minus 3 grams. Right, I've just written the same thing in the numerator and denominator. I just, instead of using the milli, I put in what it actually means, 10 to the minus 3. And if you do it this way, because sometimes people get confused, they say, okay, do I divide or multiply by 10 to the minus 3? Well, if you do it this way, you'll never mess it up, right? You'll always get it right, because milli is 10 to the minus 3, right? So when you carry that out, you'll get 55.2 times 10 to the minus 3 grams, okay? All right, let's try another one. 4.5 nanometers to meters, right? To meters. So what's a nanometer? It's 10 to the minus 9. 1 nano equals 10 to the minus 9, right? So I'm going to write nanometers on the bottom and then 10 to the minus 9 meters on the top, right? That cancels, and I get 4.55 times 10 to the minus 9 meters, right? Pretty straightforward, right? How about this one? 0.0255. I need a sheet of paper here. Uh, 0.0255 grams to milligrams. Okay, I know I want grams on the bottom, and I know I want to get to milligrams, right? And what does milli mean? 10 to the minus 3, right? So milligram, right? My grams cancel, and that turns out to be 25.5 grams. Okay, does that make sense?
Yeah.
Questions?
Isn't it milligrams?
Milligrams, correct.
Sorry.
Milligrams, 10 to the minus 3 grams. What did I say? Something different?
Yeah.
Oh, sorry about that. I meant
You have grams on your answer. That's why.
Yeah, you have a gram.
Oh, I see. Yes, thank you.
Yeah.
Thank you. I
No
see what my mistake was. Yeah, thank you. Good catch. Please always correct my mistakes.
Did you put the 10 to the minus 3 on the bottom, so it would actually, you could also write it as like 10 to the 3 on the top?
Well, see, you could do it that way, all right? That's the same thing, but you're more likely to make a mistake that way, right? Because what you'd have to do if you did it that way, you'd have to write 10 to the 3rd milligrams per gram, right? Is the way you'd have to write it. And it's just easier, right, to remember that milli means 10 to the minus 3. So this and this correspond to each other, right? So if you write milligram, just write milligram again in the denominator, right? And it's like multiplying by 1, right? Because you have milligram over 10 to the minus 3 grams. So I think it's a little easier to do it this way. If you feel more comfortable that way, that's fine. But I just think this is going to be more foolproof in the long run and prevent mistakes.
As far as like the sheet that we're allowed to use during the tests, are we allowed to put like the conversion units and
You
stuff?
can put whatever you want on that sheet, but I'll give you all conversion factors on a separate sheet in addition to that.
Cool.
All right, here's a question for you. So let's try that one. Remember, milli means 10 to the minus 3. Okay, 10 more seconds. Try to finish up in 10 seconds. Okay, the correct answer is A. And there we go. Looks like 75% of you got the right answer. A few of you put B, and that's because you made that mistake of writing the conversion factor wrong, right? So again, what you want is you want liters in the numerator, in the denominator, so it'll cancel liters, and you want milliliters in the numerator, right? And then you got to remember that milli means what? 10 to the minus 3. So if you do that, notice it's milliliter, 10 to the minus 3 liters, right? There's a correspondence between this and this. And if you do it that way, again, you'll never make this mistake where you accidentally go the other way, all right? So this turns out to be equal, liters cancel, and you get 55.2 milliliters, okay? So keep that in mind. Again, if you put B, remember to write your conversion factors like this, right? So how would, so any time you write, so if you have 1 nanometer is equal to 10 to the minus 9 meters, right? So the conversion factor would be either 10 to the minus 9 meters over 1 nanometer or 1 nanometer over 10 to the minus 9 meters, right? Notice that this and this correspond to each other, right? And if you write your conversion factors that way, you'll never get it wrong. Does that make sense? Questions? Comments?
I already memorized the liters to milliliters, all these measurements. So 1 liter is equal 1,000 milliliters. So I write it that way. That would be a problem, or do I have to write it?
Yes, yes. If you've already done it and you're comfortable with that, it's not a problem.
All right.
Okay. Let's do another example here. Here we're going to convert 30 milliliters to quarts. All right. So we got 30.0 milliliters. and we're trying to get to quarts, all right? So notice we have to do two things here. We have a conversion factor from liters to quarts right here. But in order to use that conversion factor, what do we have to convert this to?
Liters.
To liters first. So we're going to do the same thing. We want milliliters on the bottom, 10 to the minus 3 liters on top. Now we're going to convert. Now we're at liters. Notice these conversion factors, you can just stack them up one on top of each other. What am I going to put on the top here? Here's my conversion factor. 1 liter is equal 1.057 quarts. What goes on top, quarts or liters?
Quarts.
Quarts. 1.057 quarts over 1 liter, and my liters cancel, right? And if I work that out, and I forgot to work that out before class, so we get 30 exponential minus 3 equals times 1.057, and you get 0.03171 quarts. How many significant figures am I allowed here?
3.
3, right? Because this is limited to 3 here. This is unlimited, right? Because that's a definition. And I have 4 here, right? So this is limited to 3. 0.0317 quarts is my correct answer. Okay? Everybody with me?
Yep.
Yes.
Perfect. All right. Okay, now we're going to look at how we can use density as a conversion factor. So density has units of grams per centimeter cubed. So anything that is an equivalence like this can be used as a conversion factor. So this can convert, for example, from centimeters cubed to grams, right? Because a centimeters cubed, if you had something in centimeters cubed, and you multiply it by the density, you'd get grams, right? So you can think of density as a conversion factor between what? Mass and volume, okay? So for example, if you have 5.5 grams of platinum and you want to know the volume, you can just use the density to get it, right? So you'd write 5.5 grams, right? Times, how would you write the conversion factor now to get to volume? What would you put on top?
The centimeter cube?
Yes. So you'd have 1 centimeter cubed over 21.4 grams. Your grams would cancel, and you'd get 0.257 centimeters cubed. How many significant figures would I be allowed here?
2.
2 on that, right? 0.26 centimeters cubed. Okay? All right, here's a question for you. Go ahead and try this. Okay, I see a few of you might be getting stuck, so I'm gonna give you a little hint to get you going in case you're stuck. You have cups here, right? And when you look at all the stuff here, notice you have a conversion factor here between cups and milliliters, right? So the first thing to do would be use that conversion factor, right? Just as a guess, right? You don't necessarily have to know exactly, but you look and you say, ah, okay, well, I got a conversion factor between cups and milliliters. So my first step might be this, right? Cups cancel. There's my first step. Now, where might you go from there? Again, look through and see what you might be able to use next. Ah, here I got this, right? So I can write 1 milliliter, 1 centimeter cubed. Now my milliliters cancel. See, I'm just using the units kind of to help me work through the problem, right? I'm using the units and the conversion factors to help me work through the problem. So now I'm at centimeters cubed. Now there's one more step. Go ahead and try that. Get that last step and vote for the answer you think is correct. All right, 10 more seconds. All right, the correct answer was B. And most of you got that. A few of you didn't. A few of you didn't quite finish either. So let me go ahead and show you what the next step is. You look here and you see, aha, I have 1.00 gram per centimeter cubed, right? So that cancels as well, right? And you multiply that all together and you get 600 grams, right? But how many significant figures are you allowed? Well, it's a little bit unclear. This is either 2 or 3, and really I shouldn't write things that way, so that's my bad. But this comes out to be, let's just say 2 times 10 to the 2 grams. Okay. All right. Now there will be times when you have to convert cubic units, right? So things like centimeters cubed, but you only have the conversion factor for the linear unit. So what you got to do in a case like that is cube both sides. So in other words, if you have this conversion factor between centimeters and inches, and you want a conversion factor between centimeters cubed and inches cubed, just cube both sides, right? But we got to remember, you got to cube this number as well as that number. So 1 cubed is just 1, so that's why you get this as your conversion factor. All right, so let's do an example. Let's say we want to convert 2.11 yards cubed to cubic centimeters, all right? And we have these conversion factors here. So the first thing we do is we go, okay, aha, I got yards and inches here. So I'm gonna do 1 yard over 36 inches, right? But notice that this is yards to the 1, this is yards cubed, right? So I gotta cube this whole thing, right? That means I gotta cube the 36, the inches, the 1, and the yards. Everything in there gets cubed, right? And then, let's see, I got to go from there to centimeters, right? So times, now again, I got this conversion factor between centimeters and inches, right? I'm going to put inches on the denominator, centimeters on top, right? And again, has to be cubed in order for the units to cancel, right? Right, so that comes out to be 2.11 yards cubed. And I'm just going to do this intermediate step here so you see what has to be done, right? This has to be, oh, sorry, I don't have that intermediate step. I'm just going to make sure you cube this, you cube that, you cube that, you cube that. When you do all that, you get 1.6132 times 10 to the 6 centimeters cubed, all right? And I'm allowed 3 sig figs, right? Because that's exact. So that rounds to 1.61 times 10 to the 6 centimeters cubed. Okay. I'm gonna let you try one. Okay, I see a couple hands. Let's see, Megan.
Yeah, back to the practice or the poll problem that we did. If
Yeah.
we didn't include the conversion of the centimeters cubed to milliliters, because it's already given that it equals 1, would that be
Sure.
considered incorrect?
Nope, that's fine.
Okay.
Megan,
Yes.
do you have a question?
Oh, you answered it already.
Okay, great. All right, very good. So here's a question for you. Go ahead and try that one.
In the question, it's only squared, Professor.
Oh, thank you. Yeah. Let's try it again. Okay, looks like most of you are done. 10 more seconds. All right, the correct answer is C. And I see that, again, a lot of you got that, but some of you got A. So what happened? What did you do wrong if you got A? So remember that you have something like this, right? 0.3. Just stop that. Sorry. You got 0.330 foot squared, and here's your conversion factor, right? But you can't just multiply by 12. Why? Because if you did that, the foot squared would not cancel. Yeah? So you gotta square this so that you get inches squared over foot squared, right? So you get 0.330 foot squared times this squared, this squared, this squared, this squared. So that gives you 12 times 12 is 144. So that's 144 inches squared. 1 squared is 1 times foot squared, right? And if you work that out, you should get 47.5 inches squared. Okay. So again, remember, you gotta square that. All right. So some of you made that mistake. Okay, I have just a couple more minutes, and I just want to show you how to solve like more complicated problems, all right? So in the book and in some videos, you'll see this procedure where you're gonna sort the information in the problem, you're gonna strategize, you're gonna solve it, and then check it. And these are the 4 steps you should always take. A lot of times students come up to me and say, Professor Trillo, I read this problem and I don't even know where to start. The first place to start is to always sort the information in the problem. All right, and I'm gonna have you sort it into what are you given and what are you trying to find. This is the beginning point and this is the end point, right? So notice right away, determine the density. Oh, okay, that's what it's asking me to find. So I'm gonna write that down, right? And then what else am I given? I'm given that the mass of the object is 149.8 grams, and I'm given that it displaces 12.1 milliliters of water, right? So that's its volume, right? It displaces that much water, right? And it's asking me to find the density. Well, that's, so now I know what I've been given and what I'm trying to find. And I'm gonna ask you, especially at the beginning if you're struggling, always write these things down because it'll help you to start seeing how the solution of the problem goes, right? And you're gonna say, oh, okay, well, density is equal to mass over volume, right? So I can, I'm given the mass and I'm basically given the volume, right? So I can just divide one by the other and that will give me the density, right? And remember that a milliliter is equal to a centimeter cubed, right? So I can just go density is equal to mass, 149.8 grams, divided by 12.1 centimeters cubed, right? And that gives me, what does that give me? Did I write that down? I forgot to write it down. Let me just multiply that out real quick. 149.8 divided by 12.1. And that gives me 12.38. So that's grams per centimeter cubed, or 12.4 grams per centimeter cubed. All right. So that's kind of how you can solve a problem. I think I have time to just start this next one. I don't know if I'm going to be able to finish it, but let me give you an idea. So here's a much more complicated problem. And again, how do you approach a problem like this? Same exact way. What are you given? What is it asking you to find, right? So you read through the problem. Rolls of aluminum foil are 304 millimeters wide. So I'm going to write width is equal to 304 millimeters. And it says thickness. Thickness is equal to 0.016 millimeters. And what maximum length? Okay, so what is it asking me to find? Length, right? What maximum length of aluminum foil can be made from 1.1 kilogram? Okay, so that's another thing that I'm given. The mass is equal to 1.10 kilogram of aluminum, and I'm also given the density, 2.70 grams per centimeter cubed, right? So there's a little more complicated problem, right? And so to solve it, you're gonna have to figure out, okay, how am I gonna get from all this information to that information? The key here is to realize, oh, wait a minute, the length, the thickness, and the width, right? If I have length, right? So here's my aluminum foil, right? If I have length, thickness, and width, and I multiply those all together, what do I get?
Your volume.
Volume, right? Length times thickness times width. Ultimately, it's asking me to find the length, right? So I could say, length is equal to volume divided by thickness times width, right? So notice, what am I given? I'm given the thickness, and I'm given the width, right? What else would I need to solve this problem?
The volume.
The volume, right? But I'm not given the volume, right? But look what I'm given. I'm given the mass, and I'm given the
density.
Density, right? And I know that density is a conversion factor between mass and volume. All right? So I can use these two things, right, to get the volume, right? Once I get the volume, I plug it into here, make sure all the units are the same, and I can get to length. All right, I'm going to give you the answer here. We're not going to have time to work it out, but the answer is 84 meters. Why don't you try that on your own after class to see if you can get to that answer, because that's what it should be. okay? We're all out of time. In fact, I'm over time. I apologize for that. I will stop here. You are all free to go. If you want to stick around, you're free to stick around. I'll be here for at least another hour to answer you any questions you might have. Thanks for coming today. Have a great afternoon. Remember to go to the pre-lab today at 5, and otherwise I will see you all next week on Monday. If you want to see me tomorrow during my office hours, send me an email and I'll be ready for you. And then remember also the help sessions as you work through all those problems, all right? I strongly suggest you start the problem set today, okay? Thank you all.
Thank you.
Thank you. Thank you.
Bye-bye.
Thank you.
I have a question.
Yeah, just one second.